Hi everyone, I just want to show you how you can use our CivilSoft Quick Structure 7 to model and analyze a roof truss. Okay, as usual, just click on File, click New. Then let me just show you the truss we are going to model and analyze. This is a truss structure shown in AutoCAD. Okay, usually the first thing you do if you want to translate the truss into our software is to kind of map out the coordinate of the truss. Usually in AutoCAD you just kind of draw lines, from end to end. You can see the way we drew some lines across from end to end, so that it will be easy to take the measurements. Then of course you also draw a line across this end. Then later, like the vertical lines, so you can be able to take the measurements. And then measurement of the coordinates. Then later you can draw a horizontal line, make sure that all the points, all the nodes of the roof truss or the truss member is covered. Okay, just draw horizontal lines this way. Okay, just use a different color from the color of the truss member so it will be easy for you to differentiate between the lines. Now, when you have drawn your lines, as you can see what we have, the colored lines, then you now measure out the coordinates. Let me also point some things out. While modeling the trusses, usually you can choose to start from a particular distance. Like I personally usually like to start my coordinate from 2 meter by 2 meter, 2 meter away from the top, and then 2 meter this way. Okay, then you can just make your modeling and then go downward. As another thing you also need to know again, while taking your measurement, you always measure from the top to bottom. That is for the y coordinates. And then for the x coordinates, you measure from left to right. It's very good that you understand the orientation, because that is actually the orientation that our software works with. As you can see, the x coordinate starts from 0, that is from left, and it increases down towards the right. The same way on the vertical axis, on the y axis, it starts from 0 on the top and then move towards the bottom. It's very good you understand, because actually in AutoCAD it's a little bit different in the coordinate system of AutoCAD, but it's good you understand this anyway. Okay, that is by the way. The next thing is for us to measure out the distances. What I will do now, I will start measuring from the left to right. Okay, I will pick the measuring tool. I can start from here, and to start with this very first point, this very first x coordinate, I will call it 2000, because I want to start my modeling from 2000. Okay, so you can get a paper and write down the coordinate. It's a little bit much more easier. Like this first one is 2000 instead of 0. Okay, then I can take the measurement. Once you click here, and then you can see this next one is 1280. But remember, we said our starting distance is 2 meters. That is 2000 millimeter. So all I need to do is just to add 2000 plus 1280. That will give me my second distance, and that will be 3280. Then the third one is going to be 45. That is 2580 plus 2000. That will give you 4580. And you just go on and on and on and on until you get to the last one. And in the last one, you can see the last one is 15560. But remember, because we're already starting at an offset of 2 meters, so to this distance you add 2 meters. That will give you 17560 millimeter. Okay, once you're through with the horizontal measurement, like the distances on x, the next thing is for you to measure the distances on y. As I said, it's a good norm for you to write it down on a paper, so it will be easy for you to translate to the software by the time we start. Okay, then the next is to take the y coordinates. Again, I will start measuring from the top. Okay, you can see, you can actually expand it, zoom in, so that you can get a clear picture of what we are measuring. Okay, that is it. Then I can take the measuring tool, start from the top, and measure all the way down. As I said, again, I'm giving an offset of 2 meters from the top. Okay, so every measurement I have, I always add 2 meters to it. It's always good to, just note that, so you are consistent. Actually, where I'm given the distance is that, of course, certainly I will have my point load, later on in the arrangement. So I want to see a space to put my point load. Okay, so you can measure from the top here. I can measure to the next distance. This is 38.8. I'll call it 39. As I said before, 39 plus 2000, that will give me 2039. Okay, the next place is the next distance on the Y is 155.6. Now 155.6, I'll call it 156. By the time I add 2000 to it, I have 2156. You just go on and on and on and on, all to the last one. So you can see I have 2726. But when you add 2000 to it, you have 4726. Okay, as I said, it's a good norm to write down these distances. So once you have your X distances and your Y distances, then you are good to go. Now, what the first thing I will do in the software is for me to go and create those coordinates. To make the modeling, it makes actually the modeling of the trusses very, very fast and much more easier. Okay, all I need to do to create the distances, I'll just go to 2, and then I will click on drawing grid properties. I can say edit x-axis grid. Okay, I'll say create, then I can add. Now you can see I have a fresh blank x-axis coordinates. All I need to do is to add. You can see I have x-axis grid 1, starting with my first distance, which is 2 meters. I can add 2000. Okay, that is under the grid line distance. I'll add another one. That will be 3280. Add another one. That will be 4580. Okay, you can see the user defined is true. Add another one. That will be 5880. Can see it's quite very simple. What I'm trying to do is to create the X distances or the X coordinates, so it's much more easier for me to map out my truss once I have the coordinates. Now, one reason why I'm doing this in the first place is that trusses, most often the coordinates are very complicated. Now, they don't usually follow a normal. You can see the grid we have here are all at 5500 interval. But because they don't usually follow a normal convention that way, so it is very difficult. The best way is to map out the coordinates so that it is much more easier, for you to make your entries and then draw the truss without going through the complexities. Okay, this is 12380. I'll add another one. This is 13680. Actually, I'm reading this from what I've already written down already. The coordinate I wrote down, as I said, is a very good practice to write it down, because truss structures can quite be very complicated. But when you write them down this way, it makes it much more easier to enter it without having to be going and be making measurements and be entering. Okay, so this is 1750. So I have my S coordinates. Cool. Then I can go ahead and create my Y coordinate. As I said, I'm starting from a distance of 0. That is the first one. And then the second one is 2039. Actually, it's also a good norm to take very good care with the Y coordinate, because sometimes they are very, very small. Make sure you measure out every coordinate, every nodal point. Make sure they are all measured out so that it is much more easier. Okay, so you don't go into complexities. Okay, so this the fifth one. Okay, this is 2000, this is 2039, this is 2151. Sorry, just made a mistake. Then this is supposed to be 2350, and then this is 2629. Then the next one is 2976. Just have to patiently enter the coordinate. Is quite very important, because the building block of the whole stuff is actually the coordinate. Once you get the coordinate right, it's much more easier to map out the trusses. And one other good thing with this method I'm using is that it will help you. Actually, you can model the element direct, but the problem is this: you might run into trouble trying to coordinate the nodal points of the element. So it makes it much more easier to bring out the coordinate. It's actually one of the reasons why we created the user defined coordinate, to bring out the coordinate, and then once you tabulate your x and y coordinates, then you're good to go. And that will save you a lot of errors. It will ensure that no two coordinates are the same, and everything is quite in order. Okay, so this is the last one, 4726. Okay, so I have my coordinate. You can also have a double check just to make sure what you have on paper is what you have entered in. It's always good. Okay, I'm good to go. Now I have defined my two coordinates. Just go to view, and then I can check user defined coordinate. Then for clarity, I can uncheck the standard or the default grid lines, and then check my user defined grid line so that I have the grid. Now as you can see the truss, the grids are all mapped out. The next thing I need to do now is to now model the trusses. Okay, so to model a truss is quite a very patient work. You must be ready to be patient. Don't complicate things. Just be patiently map out the truss, map out the grid line. As you can see, just by making the entries, by going to tools, bringing up my grid, drawing grid properties, create my own user defined grid, and then the software pull them up for me, so that I can be able to use this to now map out my elements with an ease, without much complications. Okay.